Hi, welcome to our presentation on ocean acidification. So what is ocean acidification? The official definition of ocean acidification is a reduction of pH in the ocean over an extended period of time caused primarily by the uptake of carbon dioxide from the atmosphere. The effects of ocean acidification include a decrease in the carbonate ion, which is shown in the bottom graph of the image. It also includes a decrease in the amount of calcium carbonate and the overall ocean pH, which is shown in the middle graph. Each line color on this graph represents a different observatory point across the ocean. Also, the formation of this carbonic acid from the CO2 increases the ocean's supply of the bicarbonate ion. All of these changes lead to more changes in the overall carbonate chemistry of the water, which affects the biological variability of the ocean itself. So this decrease in pH leads to more acidic ocean water. From 1765 to 1994, there's been a global mean decrease of 0.08 in the pH of the ocean. This image on the right also shows how waters have become more acidic over time. And it starts with the first map in 1875 and ends with a third map that shows newer observations from 2013. And as you can see, the map slowly becomes less blue and more yellow, signifying a lowering in pH. And this image compares a higher, more basic pH on the left to a lower, more acidic pH on the right. And this image does a really good job showing the process of ocean acidification by showing the larger arrows on the right, which signify a higher concentration of absorbed carbon dioxide, leading to fewer carbonate ions and eventually affecting marine life and variability, which we'll talk about later.
Next, we're going into what causes ocean acidification. The underlying cause is rising carbon dioxide emissions in the atmosphere, and the root cause of this is anthropogenic causes. Looking at this graph, you can see that carbon dioxide, atmospheric levels, and emissions are both increasing since about year 1900. You can see that there's an exponential growth that has become steeply increased towards our present time. Now, this is the ocean acidification process. The first step is that the ocean absorbs atmospheric carbon dioxide. Carbon dioxide is allowed to be dissolved into the ocean since it is soluble. The second step is that carbonic acid is formed when dissolved carbon dioxide and water combine. The carbonic acid will break down to form carbonate and hydrogen ions. Carbonate is decreased because it will continue to bond with one hydrogen to form bicarbonate. This causes an increase of hydrogen ions since the formation of bicarbonate only uses one. This results in the pH becoming more acidic because of the presence of the hydrogen ions.
As you have heard, increased carbon dioxide in oceans creates carbonic acid, which creates a corrosive ocean that degrades the quality of exoskeletons, making organisms that rely on them especially vulnerable and therefore at risk, especially as calcium carbonate saturation declines. Furthermore, ocean acidification also leads to coral bleaching, or the whitening of corals as a result of the loss of energy-providing symbiotic algae, which threatens the productivity of reef systems. Now we'll discuss changes expected to see in the future. The journal Nature Communications affirms that decreased carbon dioxide emissions in the near future will not be enough to stop the damage occurring in the Great Barrier Reef. With this in mind, it is likely to expect a rippling effect across ocean ecosystems as we continue on this path and proceed to destroy reefs. In fact, the EPA states that 25% of all marine life is dependent on coral reefs for some length of their life cycle. This means that the loss of coral reefs would cause a massive shift in marine ecosystems, uprooting normal function and forcing ecosystems to make massive adjustments or risk extensive loss. The Global Change Biology Journal affirms that ocean acidification alters the behavior of animals, as high CO2 alters the function of neurotransmitters, metabolic rates, and the sensory systems of organisms. Lastly, a loss of biodiversity will result as complex environments like coral reefs die, making it difficult for certain species to find habitats.
Okay, so now we come to effects on people and wildlife. So ocean acidification reduces the populations of small marine animals like oysters, which leads to a shortage of food for animals higher up on the food chain. Ecosystems. Coral reefs provide food and habitat for various marine animals. Any harm done to them due to acidification could disrupt the entire ecosystem. Ecosystem services. Oceans provide services like commercial fisheries, recreational fisheries, subsistence and traditional shell fisheries, and aquaculture, and also tourism activities like snorkeling, which are affected by acidification. Traditional tribal fisheries. Indigenous communities in Alaska depend on coastal resources not only for food, but also cultural heritage. This could be lost due to the harmful impact of ocean acidification.
Thank you all for coming to our presentation on ocean acidification.